Okay, so here we have an inclined surface which the inclination angle is 37 degree, and there is a spring at the top of the incline. So this is the spring here, this one, and the spring's K is given 170 Newton per meter. The lower end of the incline is at a distance of 1 meter d, uppercase D, which is this distance is 1 meter when the spring from the spring when the spring is in relaxed position. So there is a canister that is the mass of the canister is 2 kg, and that one is pushed against the spring, so pushed in this direction against the spring, of course, until the spring is compressed zero point 0.2 meter and then released from rest. So that happens, and then we have to find, so as a result what will happen, there will be a spring potential energy, which when the spring is released, the spring's potential energy will be transferred to the canister's energy, and canister will gain kinetic energy as a result. So we have to find what is the speed of the canister at the instant the spring returns to its relaxed length. So when the spring is returned to its relaxed length, that is, it was compressed 0.2 meter, let's say up to that much, when it comes back here in relaxed position, what will be the speed of the canister? And then the second part is, what is the speed of the canister when it reaches the lower end of the incline, so here. So let's first try to find out what is the stored potential energy of the spring when the spring is compressed 0.2 meters. So that we know will be half kx square. K we know, and x is 0.2 meter. So 170 times 0.2, this much, which we get to be 3.4 joules. So this is the spring's potential energy, and when the spring is released, the canister being attached to it, it's attached, not attached physically attached, but it's just because the canister was pushing the spring. So when the spring is released, the spring will push the canister back. So this potential energy of the spring will be transferred to the canister as a kinetic energy, so the canister will get a velocity. So the velocity that it will get once the spring is just released, that will be the total. This energy will be the kinetic energy. So half mv square, mv square. So that v will be 3.4 into 2 over m, of course, which is 2 v square, so v is becoming 1.84 meter per second. This is when the spring is just released. But we have to find, the first part of the question is when the spring reaches its relaxed position. That means when the canister moves 0.2 meter, moves back. So it was compressed 2 meter, the spring, when it is again goes back to its relaxed position, it will be there will be a movement of 0.2 meters. So the spring, so the canister will have traveled 0.2 meters by that time. So that will be, let's say, v1 square will be, there will be an acceleration because of the gravitational acceleration of the due to the inclination. So that will be here, since this is not downward fall totally, there is an inclination, so g will be replaced by g sine theta because of the inclination. So the acceleration will be that way, and that will be g sine theta. So v1 square will be u1 square. So if we call this u, I don't know, here I have written v square, but this is the initial velocity, so that is u square plus 2g, and the distance x we can write. So g, instead of g I will write g sine theta. So that's the acceleration, gravitational acceleration in along the inclined slope, and then this is x, that will be 0.2. So here we have 1.84 square plus 2 times 9.8 times sine 37 degree times 0.2, which is x. That was the compressed amount. So v1 we get when this is the spring is at relaxed position. That is our answer of answer to our question A will be, if we solve this one, we get 2.4 meter per second. So that's there. Now we have to find what is the velocity of the canister when it hits the lower end. So when it just hits this part here. So that means if we go from initial velocity when the spring was just released, which was 1.84, then it will have traveled 1 plus 0.2 meter. 1 meter is this distance, and then the compressed part 0.2 meters. So what I will do is maybe V final, that will be u square plus 2 g, again g sine theta times x. So let's just say I don't know, let's just say d plus 0.2. so that's the total distance. 0.2 is the compressed part, and then d is the length from the relaxed position, the distance from the relaxed position, so this much. So here we will have u is again the first the initial velocity, basically when the spring was just released. 1.84 it was, as if I recall it correctly. Yep. And this is when the spring is in relaxed position. So the canister has already moved 0.2 meters. So here for this one, when the canister has moved all the way down up to the end, which is 1 plus 0.2 meter, so that will be times 2 times 9.8 times sine 37 degree, and then times 1 plus 0.2, that is 1.2 meters. So if we solve this, what we get is, this will be square of course, because we are using that formula, v square is equal to u square plus 2as, basically 2as, or v square, sorry, u square plus 2gh, whatever. So here the acceleration is g sine theta, of course. So this one, what we get is 4.19. that's what I have got, 4.19 meter per second. So when this one is solved. So yes.